Hello students, my name is Sagar Hota. My PMR PhD scholar. Today we will discuss week 3 of the live discussion section. This section for lecture 11 to lecture number 15 by Professor Sagar of the subject Turbulent Combustion Theory and Model. As you already know, I follow this book, An Introduction to Combustion Concept. First we do some MCQ. We will go for the numericals. The rate of reaction depends on the temperature. So okay. Sometimes this simple question. Obviously the answer is okay. And the rate of reaction, that means the rate of reaction and also one more thing I can tell. Effect of temperature terms of temperature means direct temperature Cp and be the rate of reaction increases with a rise in temperature. Now we know only the function. The rate of reaction is a function. So now here we know the rate of reaction is directly proportional. So the rate, if the rate of reaction will rise, temperature will also. Now, which of the following represents the Boltzmann factor? I think we also see in the previous class, but we don't know what exactly this term represent. Boltzmann. So answer is power minus term you already know. And in which equation this Boltzmann factor will come? First this is 10, this is Boltzmann. Boltzmann factor, where this thing RNA Next question, which of the following is not a direct factor affecting the rate of reaction? So obviously you know temperature is a factor, then reaction is there, and what is the order of reaction? Okay, or maybe it is the order of reaction of the product, or it is the order of reaction of the reactant. Okay, all these things, mostly it's a reactant. Okay, so those things actually taken into account. Molecularity of the atom. Okay, if there is excess oxygen. Of catalyst we never talked about in this kind. Okay, all these things, not much about the catalyst. We may use here mostly the temperature and the condition in which we one more problem with catalyst is that the what catalyst it can increase the of reaction in both forward and reverse direction. We need is only taken or it taken part in reverse direction or both. What happens to the value of delta Z of a reaction when a catalyst added to it? Here gives major rule and the catalyst taken into consideration. I already told you catalyst having no use, having presence of catalyst having no use. Same thing you can apply here also. Here they are telling when catalyst is added, catalyst having no role in anywhere the combustion reactions. Okay, so basically the catalyst is also added, no change. So going to C. Delta G is a rate function. So that means what? It does not take depends upon the enthalpy, but here it's the change of not enthalpy, rate of reaction for the thing on the type of reaction. Third, as a result, does not depends on, okay, that's what the role of, but what is the answer then? False. Sometimes it's called enthalpy. We are sometimes also people are telling that it's enthalpy of reaction. Don't confuse your thermic or endothermic. Delta H delta, or what does it all? Served, or some of the people asked in an answer forum. Question there in the options are or will take solve the problem. Okay, regarding this, this option is not there. The answer, okay. This option is not there in the your option in the assignment one question. For out question, the propane reaction is given with air in stoichiometric equation. C3 A time O2 plus 76 times N2 to B times CO2 plus C times H2O plus B times. Okay, so now we just balance the carbon, hydrogen and oxygen and nitrogen atoms. All the atoms we can now balance. Okay, so that to find out A, B, C, D. Okay, now here in the question, if you can see, it's given stoichiometric air fuel ratio. Means what? It means this all these conditions are there for what? Stoichiometry. There is no excess air, or there is no, means that it's not in a rich condition or it's not in a lean condition. Okay, now this is the reaction. What is the condition for rich and lean? That's already okay. Here we only deals with the stoichiometric condition. Okay. So if we balance the carbon atom, you see left hand side is 3, right hand side it's B, equal to B, means 3 for C3H8 and B for what? CO2. Okay, balance. Then if you see hydrogen atoms, okay, in C3H8 it's 8, okay, equal to what? Where is again it's there, C it's there, okay, so 2C H2. Okay, so now what is C? Now we balance the oxygen atom. You see the oxygen here in left hand side it's 2A, okay, right hand side equal to 2B for CO2 plus C. Okay, so 2A equal to 2B plus C. 2A equal to 2B plus 2A equal to B already you know 3, B already you know 4, equal to 10. So A comes out to be 5. Okay, so now we balance the nitrogen atom. You see 3.76 into A, okay, in left hand side, and right hand side it's what? 2 times D. So 3.76 with nitrogen again, at nitrogen atom we are multiplying, so we again multiply by 2 into A equal to 2 into D. Okay, 2 get cancelled. A we already know 5. So now you calculate D as 13.8. Okay, 3H8 5 times O2 plus 3.76 times N2 H2 O2 for H2O plus 18.8 times N2 with the air fuel ratio. Air fuel ratio is equal to enough air, enough fuel into molecular rate of air to divided by molecular weight of fuel. Okay, this is the molecule 0.85 we are. Okay, what is the number of moles of air? 1 plus 3.76. Since here if you see O2 plus N2, 1 plus 3.76, 4.76 into A. Okay, and 1 mole of what? So molecular weight of air what? 0.5. Okay, if you calculate C3H8's molecular weight, it will be comes out to be 44.097. Okay, solve it, you get 15.57. okay, is equivalent to your option. If you see 15.78. okay, answer, because if they don't use all these decimal places, they will get some 15.78. I taken all the cases, so it is get 15.57. it's coming. Okay, now one more thing is that it's all these reactions are coming under what? how it's in which condition all these reactions are going on. Okay, already given in the question, stoichiometric airfoil ratio. Okay, and stoichiometric, there is no other lean, rich, nothing given in the question. So we assume the equivalence ratio, if they want to find out, there is no condition for the equivalence ratio, and the default value for the equivalence ratio is what? 1. We assume it's as stoichiometric, and the value is comes out to be 1. Yes, Ramesh asked.
Sir, nitrogen in question he has given us 28 as molar weight. Is it correct? Or it is 14?
It's actually wrong. Actually 14. Okay, it cannot be
Yeah, okay.
28. Actually.
That's
So anyhow, I don't also check all these things. What is correct? I only
yeah.
yeah.
Okay, sir.
Okay, and that's also good point. Yeah, it should not be 28. It's 14. Okay, so this will be your answer. Actually, this option is also not nowhere given. Okay. So this I just also created this option 1 and 15.78. There are actually some, I think 15.78 and 3.63 is the, I think, given option. The equivalence ratio anyway cannot be this much high, 15 point some value in any kind of whatever. This is your answer 1 and 15 point. The question very basic thermodynamics, but we should know how to master. Okay. With this kind of questions, you can expect it. Now consider an equimolar mixture of oxygen and nitrogen at 400 Kelvin and atmospheric. Calculate the mixture density rho and the mixture molar concentration C. Okay. Here 3.1 all this second third addition 3.1 is the question. Write down in a proper way. Okay, starting from what is given. Okay. Molar mixture O2 and N2 at 400 Kelvin and what 1 atmosphere. Since temperature is given, pressure is also given. So what do you need to find? Mixture density, the molar concentration. Okay, mixture molar concentration. It as the molar concentration represented as what we assume in this kind of are given. So always assume idea. Just go to our solution part. Formula: the molecular weight of the mixture equal to x of O2. I tell x, you can tell it chi or x, whatever. Tell it x for my convenience. The actual notation will be chi. Okay. chi-square distribution studied in your probability statistics. So edit x, not a very big deal. Okay. So O2 equal to of O2 by n of total. That means what? This is your molar concentration. Okay. Will be the molar concentration already given, I think. Equimolar mixture of O2 and N2. Okay. Equimolar mixture means 1 mole of oxygen, 1 mole of nitrogen. Total 2 moles. So 1 by total number of moles is 1 by 1 plus 1, that is 2. 1 by 1 plus 1, 1 by 2 of N2. If you want to find out, 1 minus x of N2 by N total equal to written complete of N2 molecular rate of N, which both are included oxygen, so both will taken care of. Okay, just now what we do, what substitute all these x of O2, x of N2 or N2 in the molecular rate of the next formula. 0.5 32 2.5 28.013 molecular rate oxygen. Calculate the values comes 30.007 per kilomole, and write down also gram per mole. In SI unit we should write down in kg, gram per mole. Now what we do, we just apply the our ideal here, find out the rho. Oh, one thing, ideal gas equation, PV equal to MRT, rho is equal to mass by volume, that's equal to what? P by RT. Or sometimes also you can write down like this, to rho RT. Now S constant equal to RU, universal gas, divided by molecular weight. Sometimes we write R bar by molecular different notation. So now it's 8.35 divided by, which is the molecular weight, 0.007. For that, molecular weight of the what? R of the mixture, 2.77 joule per kg Kelvin. What is the rho of the mixture? What is P? What? In kilopascal. 1 atmospheric 101.325 kilopascal, 127 joule per kg. Solve it at 914 per meter cube. Then we Can we apply the ideal gas equation? In molar basis. Is equal to nr bar T. Anderson's formula. By r bar is equal to 101.3 divided by 1315 400. 0.5 kilomole per minute. Okay. Calculate the mass fraction of the oxygen or nitrogen in the mixture given in the problem 3. So it's equimolar mixture. That means equimolar. Just from the previous question. We now the molar concentration fraction. Sorry, molar fractions. Now it's mass fraction. At 400 1 atmospheric. At y. Mass fraction represented by y. YfO2 YF. Assumption same, ideal gas. So n of O2 by n total. What is the formula of X? Already know X02 equal to n of O2 by n total 1 by 2, and of n2 is equal to n of n2 by n total. So now the molecular weight of the mixture 0.532 plus 0.5 28.013. I am writing all these things because if somebody will see it for first time, he will not going to where this 30.00 details, so that we were also future. What is the formula? Okay, well, y of O2 mass fraction 5 by 2 equal to x of O2 molecular weight of O2 divided by molecular weight of the mixture. Of just substitute 'and go for YFN. 0.467. It's come. You can use the formula, or you can directly just do the 1 minus. Y of N2 is equal to X of N2 molecular weight of N2 by molecular weight of the mixture equal to 0.5, 28.013, 30.07. Y of N2 is equal to 1 minus Y of O2 0.46. Got that? Okay, 2 ways you can do it. Okay, now look like it's a lengthy question, but it's actually very simple and very short question. Estimate the value of the binary diffusivity of N-octane air at a temperature of 400 Kelvin and pressure of 3.5 atmospheric. Utilizing the value given in Appendix D, also compare the ratio dREF by T at temperature 400 Kelvin and 3.5 atmospheric pressure with a ratio of ρD products, that is ρ dREF by ρ D at 400 Kelvin and 3.5 atmospheric. REF means reference. Okay, reference temperature and pressure. Okay, maybe two at it will be in 298 and 1 atmospheric pressure. Let's see what is given. N-octane in air 100 Kelvin and 1580. First we find out what is D. D is binary diffusivity. Appendix D. Okay. Also compare the DREF bit, all these things. Means to find out okay and rho d by so of the assumptions we can take. Ideal gas behavior. And second is here binary diffusion. This thing I think already covered in the what is binary diffusion. What are the formulas are already covered. So I just down the formulas. Okay. So diffusion of state. What are the formula for binary diffusion we have? Okay. Except some of the formula. L gas T is proportional to T to the power 3 to the power minus 1. Let its number 1. So D is proportional to T to the power or 2. Now we solve for first bit. D by DREF is equal to D by TREF to the power 3 P by PF power minus 1. Okay. Here actually the reference condition is different. Okay, for binary diffusion the reference condition is actually instead of 298 Kelvin 273 Kelvin. Okay. Accordingly the DRE value also calculated at 273 Kelvin and 1 atmosphere. So this is taken from appendix that I certain book, third edition, an introduction to combustion. Just substitute all these values. The DREF will be 0.10 to the power minus equal to temperature hour 400, reference temperature 273 Kelvin. Okay, 3.5 atmosphere by 1 atmospheric minus 1. Calculated diffusion 2.559. What is the formula for diffusion? The unit for diffusion meter square per. The similar way, the second bit we know D by DREF is equal to 2. Rho D and V it is Okay. So what is d by d area? D area will be 0.559 into 10 to the power minus 6 divided by d area will be 0.505 into 10 to the power minus 5. Okay, equal to what? 0.507. Okay, this is your d by d area. Now if you calculate rho d by rho d area, we have already the formula by d area to the power 1 by 2. Okay, equal to what? If you calculate, d is 400, d area is 73 to the power 2. So that 1.2. So now you see the values. They actually what they want. They asked dref by d. Also compare dref by d and rho d ref by rho d. So got the plan. But what we get to know most, see, get to know one thing, that by f less than rho d by rho d. Okay, this is what the comparison. If they want comparison, I just just also a very big question, but because here all the beats are itself a short question. Now what's the question? The liquid NHN in 50 mm graduated cylinder. The distance of the liquid gas interface to the top of the cylinder is 20 cm. The steady state NHN evaporation rate is 8.2 10 to the power minus 8 kg per second, and the NHN mass fraction at the liquid air interface is 0.482. The diffusivity of NHN in air is 8 into 10 to the power minus 4 meters square. Determine the mass flux of NHN vapor. Give units. Determine the bulk flow NHN vapor. with the bulk flow at the liquid gas interface. Determine the diffusional flux of an hexane vapor at the liquid gas interface. The things we need to. Okay. That is what we do. We just directly write down what are the things to find out, and we will solve. Okay. The plan. M dot C6 H14 equal to, okay, mass flow rate what? The mass flow evaporation. Okay. How much hexane will evaporate? Okay, that we represent as M dot. Okay, so M dot of C6 H14 is 8.2 10 to the power minus 8 kg per. What is the diameter? 50 mm. 0.05 meter. What is the length? 20 centimeter. 0.2 meter. Okay, IF C6 H14 of I equal to 0.48. So you see the hexane mass fraction at the liquid air interface is 0.482. Okay, mass fraction given for the at the interface is represented by I. Okay, 0.482. And one more thing is given, the diffusivity also. 6 14 and air 8 into 10 to the power minus 4 square per second. We just directly write down what is that need to find out. Okay, to find M double dash C H14. This is called what? Mass flux. Okay, so this is the first thing to find. How we can find out solution. Okay, dot of C6 H14 is equal to M dot of mass double dash means per cross sectional area. Okay, got the plan. By cross sectional. Okay, M dot of ID square by 4. Circular cylinder having circular cross section. 1 2 5 1 5 by 4. 4.6 minus 5 kg by 10 meters. Start the plan. P weight, mass flux, and they want the bulk flux. Okay, open X and mass flux done. Now this time for bulk. Formula of bulk flux is bulk flux means just multiply the mass flux with the mass fraction at the interface. This is the formula. Here bulk flux. Four point 176 10 to the power minus 5 into 0.482. Point 013 10 to the power minus 5 second meter square. Now, okay, as which is the what diffusional flux. So d by L flux. Okay. Now for diffusional flux, we'll apply basic formula, which is the what Fick's law. Fick's law. Write down law is equal to dy 6 14 x equal to your for diffusional flux. So what mass flux minus your bulk flux equal to 1 minus y of d6 just substitute the values 1 minus 0.482 4.176 10 to the power 12.2.163 10 to the power minus 5 kg second per meter square. Go to our next question. So now this is a derivation problem. Okay. D by dx of rho bx into a equal to 0. Okay. Okay, so what to prove this thing, as left hand side and right side, have to just open this expression. What actually we need to prove, rho bx into a equal to 1 by rho. Okay, so they write in half in the question, but when you have to solve, you have to write full. Okay, 1 by bx volume in the volume x component of volume. Okay, no, sorry, x component of velocity, dx 1 by a dA by dx equal to 0. Solve it. Rho vx into a is equal to c1, we know. Okay, a equal to c1. But continue to on of rho vx into a is equal to ln of, let it be c2. So now is ln of rho vx into a, ln of rho, ln of vx plus ln of a is equal to c2. Now what we do, we just take the what derivative, okay, on both left and right side. One by rho of into a rho by d a by dx, okay, equal to what, 0. Now whatever this expression is there, this is not equal to 0. Okay, we can just take it to the RHS and multiply to 0, and term can be cancelled. Rho bx into a, write down the final expression, d by dx of rho bx into a equal to 1 by rho d rho by dx plus 1 by vx dvx by x plus 1 by a dA by dx to 0. Next question. Also derivation. Here we deal with the ideal gas. E is equal to rho into Ru by T by molecular weight of the what? Mixture. D by dx of rho Rut by molecular weight of the mixture Ru by dx. The mixture in denominator, so is sec ln of equal to rho Rut by molecular weight of the mixture. Ln P is equal to ln rho ln Ru ln T minus ln molecular weight of the mixture, taking derivative with respect to what? X. By P by dx Ru rho minus, because you already know your minus is there, so molecular weight of the df Okay, one more question can solve. Okay, what you need to prove? Prove that. Okay, prove that D of molecular weight of the mixture divided by the divided by the mixture square enough. Now how will molecular weight of the mixture equal to of I inverse. Okay. That means 1 by molecular weight of the mixture is equal to summation of Iy by molecular rate of I. Now what do you do? Take the derivative on both sides. Y of is equal to y of summation of Iy by molecular weight of I. So now what is the plan? So just take the of the square of molecular weight of the mixture divided by x to summation of what I done. I just take the summation outside of dy dx so that I can take the derivative of y trick here. So now just rearrange the things. D of molecular weight of the by dx equal to minus of molecular weight of the mixture square summation of 1 by molecular weight of I. Okay, because molecular weight of the I is a what? A constant term. Okay, just take it outside. Okay, and just take the differentiate of what? Dy by dx. But because there is a summation in both, so under 1 by molecular weight of I is there in the sum. same thing. Group. We end. Thank you very much for attending the section. If you have any doubt, you can ask my YouTube channel Sumit Sagar. Okay, in the comment section. Any doubts regarding the lectures, all these things you can ask in the and answer forum in the NPTEL assignment. All this that question and answer forum. Okay. Try to solve also some of the more problems in the these are the some basis means what the basis for your solving the problems. Just take this basis and try to solve some more problems. Certain book without anything. And
Thank you, sir. Thank you. Thank you, sir. Thank you.